Ah,
Do you love Gantt charts? Here's how easily you can build one in ClickUp. Let's map out the tasks for your Gantt chart in this list. Perfect. Now, let's add a Gantt view. Set the dates for your tasks, and voila, we've got a Gantt chart. You can also set dependencies, adjust timelines,
woohoo! Welcome back. Another streaming. Subscribe, comment, drop a like if you haven't yet. Last time you finished the Amphibians app, aka you click on something and then displays the description of the little frog. Recently we did a few PLC and FANUC sections because it would be useful for my day job. But today, let's come back to Android and let's take the quiz that I forgot about most materials for already. So let's go. Just one quiz left. Yep. I have to get to it and then you make sure to display it. Just guessing. The code would be more like a fixed thing. Message is more customizable. It has to be JSON. I think this file. though. Unity dependency, for sure. Internet access to the network, I guess. I don't think you need COIA necessarily. I think COIA just to display images. The object, you gotta make it a singleton. Like, store everything in the single one thing. Because it's expensive to create many of them. Layout. Oh, scroll vertically actually. This one honestly don't remember at all. Search is the query. Google is the host. The path is the whole thing. Parameters is Q equals Android, I guess. Or Android. More than just the hard-coded value. I don't know if it creates a code, like a middleman, like your translator almost. He's gonna say yes. Missing this one. This has nothing to do with JSON. See? Boy. You sure? But this is not true. Oh. Surprising. Drop those two. I'll do this one next. Really? Okay. Guess. Oh, the big query. Guess would be path. No, I'm trying parameters. Okay. That works. Cool. That'd be the end of the video for the quiz. Thanks for watching. See you next video. Just set that. I'll be right back. Actually. View a little bit.
Client and the server. A client is always available, and with the kind of networking we'll be discussing, there are two different parts to consider: the client and the server. A client can be a web browser or any other app on a device that makes a request to a server. The server, which you can think of as a computer, knows how to take the request and send a response back. Here's an analogy that may be helpful. You could think of the server like an ATM and the client as a person trying to make a transaction. The ATM machine is always available and waiting for someone to interact with it. The ATM handles each person's request differently depending on what the request is. For example, withdrawing money, depositing a check, and so on. Going back to the client-server relationship, many different clients on devices like phones, desktops, laptops can send requests to a single server, and it's the server's job to process each request and send back the appropriate response to each client. The client and the server use something called HTTP, which is a protocol to communicate with each other over the internet. It includes specifics on how requests and responses should be formed so that the client and server can understand each other. Let's look at how a web browser like Chrome can make a network request. We can go to google.com and on how requests and responses should be formed so the client and server can understand each other. Let's look at how a web browser like Chrome can make a network request. We can go to google.com and then type in Android as a search term. This is what a simplified request would look like. Each part of the request has a specific purpose to help the server understand the client's request. This request starts with an HTTP method. This is a GET request, meaning that we're getting a resource from the server, which in this case is the web page with the search results. The request also includes an endpoint, a host URL, and an HTTP version. Furthermore, the request contains headers with additional information about the client itself or about the data we're trying to fetch. Don't worry about understanding all of the headers and just focus on the key parts of the request that we pointed out, like the GET method, as well as the google.com host and endpoint. Now let's take a moment to break down the request URL into its components. You've likely seen website URLs all the time, such as in the address bar of your web browser. The URL starts with a scheme, followed by a colon and 2 forward slashes, and it signifies what protocol to use. In this case, the scheme is HTTPS, which stands for Hypertext Transfer Protocol Secure, as requests to this URL are secure. Google.com is the host, which corresponds to the domain that the request is being sent to. The specific resource that we're trying to access is specified with a path, with each segment separated by a slash. This path or endpoint corresponds to a specific task on the server side, such as getting search results. In some cases, you could provide additional data after the path in the form of parameters, such as specifying the search query in this example. And that's how the request URL is composed. You'll notice that the HTTP method in this request said GET. HTTP has different possible methods to help the server understand which type of operation the client is trying to perform. A GET request specifies an endpoint pointing to the exact resource that the client wants. In addition, GET requests can also be more specific by appending additional parameters to the URL. As mentioned, these are added after a question mark at the end of the path. If there are multiple parameters, they are separated by an ampersand. Here's an example. In this YouTube video URL, the first parameter v is for the unique identifier of the video, and the second parameter t is the number of seconds into the video where we should start playing from. To create a new resource on the server, we can use the HTTP post method. Within the request, the client needs to include the new data to be added to the server. A post request will typically include at least one additional header specifying the type of data being posted, for example, if it's text or some other media type. The put operation replaces one piece of data in its entirety with another piece of data. You can think of it as updating a resource on the server. Finally, the HTTP delete method represents a delete operation. As you'd expect, you'd use a delete operation to remove a specific piece of data from a server. Using a social media app as an example, let's look at how the app would have requests that use different HTTP methods. When the user opens the app, it would be useful to fetch the list of all recent posts so they can see what their friends posted. That would be a GET request. When the user wants to add a new post, send the new information in an HTTP post request to the server. When the user wants to modify an existing post, send an HTTP put request to the server with the updated post information. And lastly, if the user wants to delete a previous post, send an HTTP delete request to the server and specify which post to delete. As you can see, it's important to specify the HTTP method in a request so the server knows what the client wants to be done. All right, those are the key points to know for an HTTP request. Let's move on to the response now. When the server is done processing the request, an HTTP response is sent back. That's how the web browser, for example, is able to show the results for a search term. Here's what the HTTP response for the search request could look like. The response includes a number, called the status code, as well as a corresponding status message. Just like the request, the HTTP response contains various headers containing additional information from the server, like the content type, content encoding, timestamp information, and more. Again, you don't have to understand all the different response headers, but here's an important one to note. The content type specifies the media type of the response. Is it text, an image, or something else? In this case, the response contains an HTML document. Knowing what type of data is in the response is important because the client app needs to know how to parse or make sense of the data in order to display it to the user. After all the headers is the actual content, which is the HTML for this web page in our example. Or the content could be an image if the request was for an image. In the code that you'll take, the response will be text data in the JSON format, which you'll learn more about later. We mentioned briefly that the response code contained a 200 status code, but what does that mean? There are many possible status codes, and they all fall into 5 basic categories. Some are used more frequently than others, so let's just talk about the common ones that you may run into. Statuses in the 200s, from 200 to 299, correspond to successful requests. If the resource returned successfully to the client, the response will carry a status code of 200. This is what we saw with our search request. Statuses in the 400s represent client errors. You may have seen the status code 404 if the client was a web browser and tried to access a web page that doesn't exist. Finally, status codes in the 500s represent server-side errors. For example, a 500 error is returned if there was an internal server error. Looking at the response status code can help you troubleshoot your app if you're not getting the response you expect. It can help point you in the direction of where to start looking for the problem. Is it a client-side issue or a server-side issue? That wraps up the high-level parts of an HTTP response and what they signify. Let's move on to talk about the server for a bit. In this pathway, you'll be building an app that makes network requests to a server. That server has a REST architecture style. A web service is considered RESTful if it abides by the following principles. RESTful services implement client-server architecture, where there is a clear separation of concerns between the client and the server. The client makes a request, and the server sends back a response. Resources on the server are identified by a URI, or Uniform Resource Identifier. Say, for example, the server stores a collection of photos. The server could expose a different URI for each photo, so you could retrieve each one individually. A RESTful service also provides a uniform interface, meaning that you can manipulate the resources with create, get, update, and delete operations. In REST, the server is also stateless, meaning that it does not need to remember the client's state between requests. Each client request should contain all information needed for the server to satisfy the request. There's also other characteristics that make a web service RESTful, but we won't get into that for now. Let's look at an example of a RESTful web service that stores messages. This server exposes a URI, or Uniform Resource Identifier. Say, for example, the server stores a collection of photos. The server could expose a different URI for each photo, so you could retrieve each one individually. A RESTful service also provides a uniform interface, meaning that you can manipulate the resources with create, get, update, and delete operations. In REST, the server is also stateless, meaning that it does not need to remember the client's state between requests. Each client request should contain all information needed for the server to satisfy the request. There's also other characteristics that make a web service RESTful, but we won't get into that for now. Let's look at an example of a RESTful web service that stores messages. This server exposes a set of URIs that a client can use to make requests. When making a GET request with the first URI, you can get the list of all messages. Or you could do a GET request for an individual message by specifying the ID in the URI. Another endpoint allows the user to search messages for a certain query term. And the last endpoint available on the server is for creating a new message, and that requires an HTTP POST request with the contents of the new message. By looking at what functionality the server exposes, you can build your client Android app accordingly. As you move forward and build more complex apps, keep in mind what you've learned here about HTTP requests and responses, and by completing the code labs in this pathway, you'll have a better idea of how to call similar RESTful web services in your Android apps. Good luck and have fun!
I did this before, something really similar at least. Honestly, I think I'm pretty ready. combine this and the amphibian app. And everything. Thanks for watching.